Which is the best statement of Ohm's law? The first thing about Ohm's law that's a key is the direct proportionality between potential difference and current strength, and you have to have a constant temperature. So the full thing reads, current through a conductor is directly proportional to potential difference across that same conductor at constant temperature. On your information sheet, you have R is equal to V over I, and therefore you can easily use that to be able to say that V is equal to R times I, and therefore V and I are directly proportional to one another because it looks like Y equals mx, which means it is a straight line. Use the graph to determine the relationship between the resistances of the two ohmic resistors. So you've got R1 and R2. You've got potential difference on the y-axis and current on the x-axis. So if I was to get a gradient, the gradient would be equal to V over I, y over x, which is, or change in y over change in x, which is equal to resistance. So therefore, big gradient, steep gradient, heavy uphill is a big resistor. So this is big resistance, and this is small resistance. And therefore, we can say that resistor 1 is greater than resistor 2. Taking a look over here, use the graph to determine the resistance of this ohmic resistor. You need to choose a point and determine the gradient. So in this case, I'm going to choose 1,6 minus 0, y2 minus y1, over 0,5, x2 minus x1, and I find that I get an answer of 2,7 ohms. And I'm sure that this is V over I, and therefore it really is the resistance value, because I've checked that Y is potential difference and X is current. Use this graph to determine the resistance of this ohmic resistor. So again, I choose a point on the graph. Let's go with 50 and 5, and I go, my gradient is y2 minus y1 over x2 minus x1, and I land up with 10. Double check myself, potential difference on the y-axis, current on the x-axis, and therefore that is equal to resistance. So it is 10 ohms, and it's equal to R. Over here, use the graph to determine the resistance of this ohmic resistor. This one's a little bit trickier. I can try and make it a bit bigger as well. So I'm going to look at gradient. Y2, this is 2,5, and over here we have got 10. So y2 minus y1 is 2,5 minus 0 over 10 minus 0, and I find that I land up with an answer of 0,25. But this is current strength over potential difference, which means I now need to take 1 over the gradient in order to get the resistance, and that is equal to 4 ohms. So A is your correct answer in this case. Then, in the next graph, determine the resistance. So I'm going to choose a point. It's about over there and over there. And I'm going to say y2 minus y1 over x2 minus x1. I land up with 0,33 ohms. What if I invert that? How do I know to invert it? Firstly, because it's I over V, which means that I need to go, it's 1 over resistance. I need to flip that answer. So resistance is equal to 3 ohms. Use this graph to determine the relationship between the ohmic resistors. Now be very, very careful, because R1 and R2, this time my gradient is equal to I over V, which means that a big resistor will have a small gradient and vice versa. Because this is the inverse, R2 is actually greater than R1, because it's a flip of what you would naturally expect. Which option best describes the relationship between the two resistors represented in this graph? So both of the B is a straight line, A tilts up over there. Straight line means it's ohmic, whilst the tilt over there means it's non-ohmic. So A is not ohmic and B is ohmic, so D is my correct answer. So when you get a potential difference and current graph, doesn't matter what's on what axis, if one of them deviates from the straight line, it is not an ohmic resistor. The next thing that happens, the other thing that can make it deviate, by the way, is when the temperature changes. But then the minute the temperature does change, it behaves non-ohmically, so it's the same sort of thing. The next one is use the graph to determine the resistance of R1. So I'm going to have to choose a point, and I'm going to go with 10 and 10. Oh, it looks very easy. It's going to be 1 no matter what, except for a detail. This current is in milliamps. So what I'm going to do is I'm going to take the milliamps and convert them 0,01 amps divided by 10 volts gives me 0,001 as an answer. But that was my current over my potential difference. So I need to now invert that answer. Resistance is equal to 1 over 0,001, which is equal to 1,000 ohms. 1,000 ohms is 1 kilo ohm. So that is your correct answer.